Good morning, ladies and gentlemen. Today you will be watching a video, about 10 minutes or so, 10 or 12 or 13 minutes, on Chapter 2, Section 4. Right? And this goal is to solve equations with variables on both sides. Now there's three key ideas here in this section. One is you combine like terms, combine terms on opposite sides, like terms on opposite sides, or different sides, on opposite sides of equal sign with the opposite terms. So you use the terms opposite in order to remove it from one side and combine it with a term on the other side. Now that's a big idea there. You got to that's a really important. Number two is you always want to keep equation balanced. What do I mean by balanced? Is you want to do same thing to the same thing to both sides. So keeping the equation balanced is important. Number three is you're going to look out for no solution or infinite solutions. Quotation marks. These are special cases. And I will talk about those in a couple of minutes. So combine terms on opposite sides with their opposite terms. Keep equation balanced. What that means is do the same thing on both sides, to both sides of the equal sign. And three, look out for no solution or infinite solutions. These are special cases when you solve equations. Those are the three key ideas that we have to keep in mind when we are solving equations with variables on both sides. So let's go ahead and do example 1. And we'll just do 3 parentheses q minus 5 equals 2 parentheses q plus 5. You see parentheses here and here, and you see a factor on the outside of one of them and another factor on the outside. So my guess is you know that you have to use distributive property. 1, 2. So you have 3 times q minus 15 on the left side of the equal sign, and on the right you have 2 times q plus 10. because the 2 factor on the that factor on the outside gets multiplied by the terms on the inside. Now, the key idea was to combine like terms with their opposites. Remember, I'm solving an equation, so you have to move this 2q to the other side and combine it with the 3q. And you're going to use the opposite of it. So you're going to subtract the 2q from itself, and they cancel. Now, the second key idea is keep the equation balanced, see? So let me do this here. Let me just use a different color, and I'll use red or green or whatever. Doesn't matter. So purple, yay. Okay, so I'm going to subtract 2q from itself to remove it from this side of the equal sign. Now that cancels, but I have to keep the equation balanced by subtracting it from the 3q. Okay. Now I get 1q minus 15 equals 10. Now it's a two-step. Now it's 2 steps. And the first step is to add the 15 to the 10. Again, we're using the opposite. And I'm doing the same to the other side, so I have to keep the equation balanced. And then I get 25 on the right. And I can divide by 1 or not. Dividing by 1 isn't necessary, but it's okay. All right, so I solved the equation and I got q equals 25. Awesome. Okay, example 2. And this problem is 3d plus 4. Oops. That. 3d plus 4. Okay, equals 2 plus 3d minus 1/2. All right, so on the left side I have 3d plus 4, those two terms. And on the right side of the equal sign I have 2 plus 3d minus 1/2. These two terms on the right side, this 2 and this negative 1/2, they get combined. And when they get combined, I get 1.5. And this term just gets rewritten underneath it, like that. And on the right, these two terms are not like each other, so we'll just rewrite them. Okay, so now we have to combine the 3d and the 3d, and the big idea is using the opposite terms, okay? So I'm going to subtract this 3d here and subtract the 3d here, and they cancel on this side, and on this side they also cancel, which is a special case. And so the equation now has 4 on the left and 1.5 on the right. And 4 does not equal 1/2, at least on Earth. So we say that this is no solution. So when the variable disappears and you get unequals, it's no solution. No solution is when one number equals a different number and the variables go away. The variable drops. In this case, D went away. Okay, we'll do one more example here, and this example is when you'll see that you have equals for equals. So we're going to get another special case. And that special case looks like this. 3 times m plus 1.5 equals 1.5 parentheses times 2m plus 3. All right, so the distributive property needs to happen here. And on the right side of the equal sign. So let's do it. 3 times m is 3m. 3 times 1.5, okay, 3 times 1.5 is what? Come on now. You can do it. 4.5. Right, equals 1.5 times 2 is 3m. And 1.5 times 3 we said was 4.5. Now, I'm going to do the same thing. I'm going to subtract the variables. This time it's 3m. I'm going to do the same thing and use the opposite term. See, on this. Goes away. Now I have to keep the equation balanced. Remember, it's all about that balance. This is the left, this is the right, and you got to keep things balanced. Okay. And I'm going to subtract 3m. And on the left side of the equation is 4.5, and on the right side of the equation is 4.5. That's infinite solutions. And that means you can have anything for x. So x can be any number, or in this case, m, the variable. Right? That's when a equals a. That's when you get the same, oops, my little b. And the variable drops. So that's that, folks. So remember, if you go back, you can stop the video and you can copy it down, and that's the nice thing about videos, I guess. You can now take a look at Chapter 2, Section 4, which is solve equations with variables on both sides. The 3 key ideas are that you need to combine terms with their opposites, you need to keep the equation balanced, and you have to look out for no solution or infinite solutions. And these are special cases. The first example, we did get 25 for q equals 25. In the second example, we noticed that we got 4 equals 1/2, which is incorrect. So that's no solution. And in the third example, we got 4.5 equals 4.5, which is infinite solutions. All right, have a good one.